Kirchhoff laws will be used to discuss about multiple loops of the circuit and complex circuits. It will be easy to discuss those. So in that, the first one is first Kirchhoff rule, junction rule. Junction rule. In that, this is the junction. The sum of the currents at this junction will be equal to that zero. How? In the sense, suppose if you take that some currents are moving towards a junction. Okay, so we can consider it as I1, I2, I3. Similarly, some currents are moving away from the junction. So you can consider it as I4, I5, I6. So which are the currents moving towards the junction? We can consider it as positive, and if it is moving away from the junction, we can consider it as negative. Let's say that I1 plus I2 plus I3 minus I4 minus I5 minus I6 is equal to 0, which means we can say the total sum, if you add that these are all the currents, will be equal to that 0 at this junction. Then what happens in the sense, what are the currents moving towards this junction will be equal to which are moving away from the junction. So I1 plus I2 plus I3 is equal to I4 plus I5 plus I6. So this is junction rule or current law, we can say. This is first Kirchhoff law, and second Kirchhoff law we can discuss now. Second Kirchhoff law is the loop law. The loop law, or we can say that potential law, or why we calling as a potential law, in the sense the algebraic sum of all the potential differences along a closed loop in closed circuit is 0. So let's say that before going to the take the definition, and we need to follow some points, some sign conventions. What are those? In the sense, suppose it is given that some resistor, we have taken something A to B. Here the current direction is given like this, current and the resistance R. Our assumption direction is like this, then our assumption direction and current direction is the same, then we need to consider it as the potential difference. We need to take it as minus I into R. If similarly, if current direction is opposite to our assumption direction, okay, our assumption direction is this, but current direction is here, then the potential difference I and R will be a positive. It will be taken as a positive. Same way at the cell we have taken that this is a positive terminal and this one is negative. Our assumption direction is moving towards a negative end, so we can take the potential difference as a negative. If another one, positive and negative, if our assumption direction is moving towards a positive terminal side, then we can take the potential difference as a positive. So these four instructions we need to remember when we are solving the board loop law. Let's draw that one circuit diagram, then we can find out. Yeah, so Let's take this another resistor. Okay, then this is current I1, this is direction, and the resistor R1 and the voltage V1. It is moving like this, current I1. Now what happens, this is V2 and the resistance R2. Now another direction of the current I2, here it is joined. Then what happens, in the sense this I1 and I2 will be coming to that here, then it will combine. We can take it as I1 plus I2, and the resistance is R3. Let's take that, the loops or the points A, B, C, D, E, F. So here our assumption loop is very important. So you can take it as, first one, if you consider A, B, D, C, if you take, okay, A, B, D, C, A. This is the first loop. First loop in the sense we can redraw the circuit. If you redraw, then we can come to know that easily to solve that. So A, B, D, C, A. So this is V1 and this is R1 and current I1, here I2 and R2 resistance V2. Then our assumption direction is, we starting from A. So let's start. Our assumption direction is like this. So first you are moving, your assumption direction is this side towards the negative side of this cell. So we can consider that one as minus V1. After that we reached here resistance R1. Then we can say opposite direction to this assumption direction. Then we can consider it as plus I1 R1. Then we reach it to the B. From B to D nothing is there. Then after I1, so same like this direction we are moving here. Now what happens, in essence our assumption direction and the current direction is both are same. Then we can consider it as minus I2 R2. And here if you see that at the cell at V2 we are moving towards positive terminal, so we can take it as plus V2. It will be equal to 0. So this is a one loop. Okay, so next one we can consider another one, that is loop A, B, F, E, A. This is another loop. Let's draw the circuit diagram for it. So a cell as usual, and so A, B, F, E. It's a closed loop, right? So we can say that similarly V1 and this one is R1 and the current direction I1. Then what happens here? Here it will be that the sum of two currents I1 plus I2 and R3 resistance. So it will be like this direction of the current. If you consider from A to B, if you consider like this, it is moving on our assumption direction. Okay, so if you take like this a closed loop, then from A you can start minus V1. After that this one I1 and R1, it will be that our assumption direction and current direction will be both opposite, so that we can take it as I1 R1. Then after coming to that B to F is nothing is there, and after that we're reaching to here R3. Then current direction, our assumption direction, both are opposite. Then we can consider it as plus I1 plus I2 into R3 is equal to 0. So like that we can solve the loop, and we can take the relation and we can do it. This is about Kirchhoff loop law and junction law.